So let's look at the stoichiometry handout in the gold packet that deals with the reaction of zinc 2 sulfide as it reacts with oxygen to form zinc 2 oxide and sulfur dioxide. So as you look at the questions that follow, the first thing that we will need for this stoichiometry question is a balanced chemical equation. Stoichiometry, remember, looks at the relationship between any two components in a balanced chemical equation. So zinc 2 sulfide undergoes a reaction. That's going to have a chemical formula of ZnS. It undergoes a reaction with oxygen, which is one of our 7 diatomics. So oxygen's chemical formula is O2. And the product that we're going to get out of this reaction is going to be zinc 2 oxide. So that's going to be ZnO plus sulfur dioxide, so SO2. Okay, as we look at the components in this reaction and we balance the equation, we need a coefficient of 2 in front of my zinc 2 sulfide, a coefficient of 3 in front of the oxygen, 2 in front of the zinc oxide, and a coefficient of 2 in front of the sulfur dioxide. Now, as we go throughout the rest of the problems that we're going to need to solve in this stoichiometry example, some of the pieces of information that we're going to need include the molar masses of all of these components. So if I take the molar mass for zinc sulfide, I want to take the molar mass of 1 mole of zinc plus the molar mass of 1 mole of sulfur, and that's going to give me a molar mass of 97.47 grams. Now, when I'm looking at the molar masses, this coefficient of 2 does not impact this molar mass at all. The molar mass only deals with the mass of 1 mole of zinc plus the mass of 1 mole of sulfur. The molar mass of 1 mole of oxygen is going to be 16 plus 16, which is my 32 grams. The molar mass of 1 mole of zinc oxide is 81.41 grams. And the molar mass of 1 mole of sulfur dioxide is 64.07 grams. Okay, so I like to build a table with my balanced chemical equation to help me keep all of the pieces of information that I'm going to need for the problem very well organized. Now, when I go to look at the next problem, so number 2, the question says, what mass of zinc 2 oxide will form if 18.99 grams of oxygen react with excess zinc 2 sulfide? So remember, first we have to make sure we understand all of the information in the problem. We're looking to calculate a mass of zinc 2 oxide. We know that we're reacting 18.99 grams of oxygen, and we know that we have excess zinc sulfide in the reaction. So remember that having excess of a particular reagent means that we don't have to care about that particular reagent in this example. So for us, it's just going to be the relationship between the zinc oxide and the oxygen that matters. So if you go up to the balanced chemical equation, what we see is that 3 moles of oxygen will react in order to form 2 moles of zinc oxide. So it's that 3-to-2 mole ratio that's going to allow us to solve this particular problem. So remember that from the balanced chemical equation, this relates oxygen and zinc oxide in units of moles. So we have to start with a unit of moles for our oxygen in order to be able to convert to any other component, including the zinc oxide in this example. So strategically, I have a mass of oxygen. The first thing I'll need to do is convert that to moles of oxygen. And from there, I can go to moles of zinc oxide. And finally, to my mass of zinc oxide, which is what the question has asked me about. Okay, so grams to moles to grams as my strategy. So the first thing I'm going to do is take my 18.99 grams of oxygen and convert to moles. 1 mole of oxygen has a mass of 32 grams. So that when you do the calculation, you should get 0.5934 moles, and make sure you label that as moles of O2. Now that we have moles of O2, now we can relate this to moles of zinc oxide using the coefficients in the balanced chemical equation. So 0.5934 moles of O2 times my conversion factor, where I need to get rid of my units of moles of O2, so that goes in the denominator. I need to convert to units that are going to be moles of zinc oxide, so that will go in the numerator. And again, this ratio comes right from the balanced chemical equation. So my oxygen has a coefficient of 3. That means this term for oxygen in the denominator is going to have a 3. My zinc oxide has a coefficient of 2 in the balanced chemical equation. So this conversion factor for moles of zinc oxide is going to also have a 2. Okay, so I have 2 moles of zinc oxide relate to 3 moles of oxygen as my conversion factor. Okay, as I use this conversion factor, my moles of O2 will cancel. I'm left with moles of zinc oxide. And when I do the calculation, I should get 0.3956 moles of zinc oxide. That puts me right here in my strategy. So the last thing that I need to do is convert to grams of zinc oxide. So I'm going to take my 0.3956 moles of zinc oxide. So this should be ZnO up there. My 0.3956 moles of zinc oxide. I need my molar mass. 1 mole of zinc oxide has a mass of 81.41 grams. Okay, when I do that conversion, I get an answer of 32.21 grams of zinc oxide. Okay, 32.21 grams of zinc oxide, and that's my final answer. Okay, that's the final answer that I get for that particular question. Now, if I move on to the next one, question number 3 says, what mass of sulfur dioxide will form if 5.661 grams of zinc 2 sulfide react with excess oxygen? So in this case, I'm looking to calculate a mass of sulfur dioxide. I know that I'm starting with 5.661 grams of zinc 2 sulfide. And I know that I have excess oxygen. Okay, so oxygen doesn't matter in this problem. I'm focused on the relationship between my 2 moles of zinc sulfide and my 2 moles of sulfur dioxide in the balanced chemical equation. Okay, it tells me that for every 2 moles of zinc sulfide that react, 2 moles of sulfur dioxide will form. Okay, so again, if I look to build my strategy, I'm starting with a mass of zinc sulfide. In order to relate my 2 components in the balanced chemical equation, I have to have units of moles. So we're going to convert to moles of zinc sulfide. From there, we can convert to moles of sulfur dioxide, and finally to grams of sulfur dioxide. So once again, just like the previous problem, we've got grams to moles to moles to grams as our strategy. Okay, as we start the problem, okay, I have 5.661 grams of zinc 2 sulfide. You can put that over 1 if you want. I first need a conversion factor that's going to take me from grams to moles of zinc 2 sulfide. So I know that 1 mole of zinc sulfide has a mass, which I calculated up here to be 97.47 grams. So 97.47 grams. Okay, at this point in the problem, my units of grams of zinc sulfide cancel, and I have units of moles of zinc sulfide. So at this point, I can go to moles of any other component, and for this problem, I need to get to moles of sulfur dioxide. So in the denominator of my next conversion factor, I need units of moles of zinc sulfide, and we know from our strategy that we need to convert to units of moles of sulfur dioxide. Okay, and in order to determine what this conversion factor is going to be, I'm going to go back to my balanced chemical equation where I see that 2 moles of zinc sulfide relate to 2 moles of sulfur dioxide in the overall balanced chemical equation. So that means I have a 2/2 conversion factor. You can reduce that to 1/1 if you'd like, but that conversion factor will always be the coefficients from the balanced chemical equation, so you don't have to reduce it if you don't want to. Okay, so that at this point in my conversion, my units of moles of zinc sulfide cancel. I have units of moles of sulfur dioxide. And from there, the last thing that I need to do is convert to grams. So we know that 1 mole of sulfur dioxide has a mass of 64.07 grams. And when you do the calculation to all of the steps, you should come up with a final answer of 3.721 grams of sulfur dioxide.